My name's Charlie Bailey. I'm the operations manager of HECO Kentucky Service out of Lexington, Kentucky. I've been asked to give a couple of case studies. The first one we're going to talk about is a 12 million gallon a day water pump. Along with that, it's a 1250 horsepower motor, vertical motor, that drives this pump. It's for our main water company in Lexington. So when these pumps go down, people in Lexington start getting real cranky. I mean, just ask people in Jackson, Mississippi. Customer contacted us to remove a vertical turbine pump that was experiencing high vibration and inefficiency. It was down to about 6 million gallons a day. The motor was tested in place and determined that it was in need of cleaning and new bearings. The spare pump was assembled on site. We'll get into that later. They keep a spare down there. The motor was reconditioned and returned, installed, wired, and commissioned, up and running. This is the site. It's actually a very beautiful place to go and work. The yellow building down there is the pump room. There's 6 of these pumps and motors in that room. You have to go down the hill on this inclined car. It can be like a roller coaster at times. There's been a few of us here that's gone down on that car. I've been on it many, many times. This is a picture of the incline going back up. Now those steps that go along there when that car breaks down, there's 337 steps. And fat people like me don't like to go up them steps. This is the pump house from the outside. You can see the vertical pumps going down, the columns going down. Just the nameplate of the motor. They are all GE motors, 1250 horse, 4160 volt. All of them are 1200 RPM. That is a picture of one of them, actually the motor that we pulled on this effort. Luckily they do have an overhead crane there that is rated to pull the motors and the pumps. There's a lot of sites we go that we don't have that luxury. Now, to get started, the first thing we have to do is bring in divers, bring in commercial divers, because down at the bottom of these pumps there's an anti-vortex device. Just keeps the water from swirling. When these pumps were originally put in back in the 80s, actually, they had a lot of trouble with cavitation and whatnot. Way back then, we got with them. We got with the manufacturer's engineers, and we came up with these anti-vortex attachments. This is half of it. There's 2 of them that go in. I said that there are 6 pumps. They have 3 of them. They have a wall, and they have another 3. So when the divers can go in when the water is below that wall, and the customer can still run 3 pumps. Of course, they can't run any of the pumps, the 3 that's on the side that we're getting ready to pull. There's been times when we've had these jobs planned and we had to call it off because we had a big rain, the river went up, and the water level's just too high. They don't want a diver getting sucked over that wall, and I don't want it either. When you're talking 3 pumps, 36 million gallons a day, there's a lot of water moving.
So this is they take this water out of the river and then treat it?
Yes, sir.
Okay.
They have this transfer car because we come out with the motor and the pump, and we take it out to the end of where the overhead to hoist is, and then we have to transfer it to a hand hoist to go back down to get to the river. We set it on this cart to get it up and down. Now, there's not a road that goes to this site. So every time we have to pull a motor and a pump, we have to bring in a barge with a crane on it. That is it's a big deal. That barge right there with that crane costs us $83,000 for a month. You rent it for 30 days. 31st day, stroke another check for $83,000. All right, we've already pulled the motor and I just throwed the cart, transfer cart, setting it on there, and then the crane will pick it up and set it on the barge. This is just a shot of the all of the columns from the 6 pumps. They all go into a common header, which is back over in here. I don't know why I've got discharge pipe up there, but guess I didn't go through it good enough.
So it's a long shaft, other words, and
It's in sections.
okay.
It's in 10-foot sections.
The turbine's down in the water then.
Yes, sir. We've already got the motor pulled. It's out, so we're starting to remove the pump. We'll hook onto it with the crane, and we'll start picking it up. And we're coming out of the river with it. This is the discharge head up the top, and that's the first column. Of course, we've removed the pedestal. Actually, it's not the discharge, it's the motor pedestal. Removed it, and we'll take it and set it out of the way. We have built these beams up that we bring in to where we'll pull a section of pipe up. We'll set it on the beam so it's supported. That way we can use the hoist. You can see the size of the pipe. You can envision the size just with the number of bolts. Those are 1.125" bolts. There, we've removed all the bolts from that first section of pipe or column. It's just a couple of my guys, plus they've already got the column out of the way and they're getting ready to pick up another one. Now, of course, within these columns, you have the line shaft. Goes from the motor all the way down to the pump. So we have to hold you've got one hoist, overhead hoist. You have to hold the column up. We have to break things loose. Every now and then we have to cut these couplings. Now these shafts are stainless steel. They're generally 4160. We use a different stainless for our shafts. The couplings are 304 stainless that we use. Once they break it loose, we set the column back down, hook onto the line shaft, unscrew it the rest of the way, and pull it out. There you can see you've got a 10-foot long shaft. All right, these are some of the columns. You can see the size of them. They're pretty good size pieces of equipment that we deal with. Here you're looking at the actual turbine pump. We're up to the we got 2 more columns to go, and then we've got the turbine pump to pull out. We've got all the columns out. We've got the turbine pump pulled out. Everything's cleared from the hole right now. Well, I don't have a picture of it, but we set a steel plate over the hole just for safety, plus we rope it off. Now, a lot of times, if we're not bringing the motor out, we'll actually dismantle this pump there on site, and we can handle the bowls and the impellers and the shafts by hand, and we can take them up on the transfer cart. So we do that to save the customer quite a bit of money. There again, here's the motor. We're getting ready to set it on the barge. It's sitting on the barge. We've got the pump laid on its side. It's on the transfer cart. We're getting ready to set it on the barge as well. But once everything's tied down, here we go up the river. We go up about 3 miles upriver, and we go to the only place that's on that section of river where we have access to get into it for a loading dock. There again, we have to pay the owner of the dock as well to use his little access to the river. Back our trailer down in there. We'll set the motor on the trailer, tie it down, and we'll take it out of the way. Then we'll back our flatbed down in there and set the pump on it. All this getting ready to go to the workshop. Now, I said that they keep a spare pump on site, but it was just in pieces. That's the best way to keep that. It keeps the weight of the shaft from laying on these rubber bearings for long-term storage. So we go down there and then we actually assemble that pump on site. That's one of the impellers. We have rebuilt that. The wear ring was replaced. This is just one of the rubber cutlass bearings that is used in these. Fairly durable. They are replaceable, but you do have to dismantle everything. These pumps, actually this is the suction bowl, the bottom bowl on it. These pumps are designed all the way up with these rubber bearings. I think the top bearing is probably a bronze bearing, the stuffing box bearing. The spare pump here is just a shot looking up in it at the impeller. It is assembled right now. It's just another shot looking at the suction bowl of the assembled pump. This is the bowl number 1, the top bowl. You can see the pump shaft sticking out there to the right. All right, we've got the old pump in the shop now. Our job starts to go ahead and dismantle it, inspect it. That inspection is all the fits are mic'd, and we look and see, is everything up to spec? Obviously, this one was not, because they had high vibration. The high vibration came from all the bowl bearings being worn out, just to an amount of water flowing through it. Of course, this is one of the bearings in the bowls, and you can see it's got some trash in it and it's damaged, it's worn. It's not the water that we drink down there is not the cleanest coming out of that river. Okay, but that's where all the treatment happens. We actually have very good water in Lexington. Another thing we found, one of the wear rings was cracked.
Built it up.
That comes from vibration. So, of course, this gets replaced.
Well, that's replaced, not repaired.
That's replaced. We machine that off. Actually, that one will just fall off because it's cracked. What we do is we'll mill a slot in it, and then we just pop it off with a screwdriver.
It looks like somebody welded on there.
No, it's not welded.
That's just wear.
Yeah. What you're thinking is weld is it's a Belzona coating. It's a ceramic coating.
Oh, really?
That's put on these, and it helps the efficiencies of these pumps. It helps that water flow a lot better.
Fantastic.
I said that every now and then we have to cut these couplings in half because they get galded on there. This is one of the couplings for the line shafts. Of course, 2 ends of the shafts. In that one, we could not break it loose. We have 48-inch pipe wrenches, and we'll actually put a come along on the pipe wrench to see if we can break it loose. We'd rather break them loose than have to cut them. We're going to replace it anyways, but just time on site, we need to try to break them loose first. All right, we've got the motor back at the workshop. The guy's draining the remaining oil out of the top bearing. These are some of the line shafts. You can see the wear on it. That's where they go through the bearings, and that's just a little bit of wear. You get a lot of vibration on it. These are the spiders that hold the line shaft bearings. Plus, you have the stuffing box, and you have the couplings down here as well. Motor to pump coupling. Just looking at the top bearing of the motor and the sump, everything was fairly clean in it. The bearings did need to be replaced just due to vibration that they had set up from the pump. Also, the mega reading on the motor was degraded. Of course, stator's taken off. That's just the rotor. That's induction. They're induction motors. They're again Brazilian-made GE motors. That's the stator. You can see it's fairly dirty. There's a little bit of oil saturation. Once you wash it, dry it, apply some varnish to it, it's ready to go back again. This is the bottom bearing. These are solid shaft vertical motors. So that's just the shaft coming out of the bottom of the bearing. I'm sorry, I'm wrong. They're hollow shaft motors. We also found some bad areas on the top thrust bearing. We got with the customer that we determined after looking at that under a microscope that there was a little bit of contamination. It was actually metal. This came from impacting from the pump. Now once the motor is put back together, of course we test it, full voltage test, no load test on the motor, verify that everything's ready to go on it. At this point we do vibration testing as well. That is the completed motor, ready to go back down there. All right, once we did all the machine work to the pump, then we went ahead and painted all the bowls. That's an epoxy paint. It's all NSF 61 certified paint. It's for drinking water. Then we're just now starting to put that pump back together. Now we could put this entire pump together because we still had the barge down there that we could get it to site. That's the completed pump. Looks a little bit different than when we brought it in. All right, motor's going back onto the barge. Barge just sits there while we do all the work in the shop. We're back at the site now. We've got the pump put on the cart, and we'll bring it up, and then that entire pump will go into storage. We go down there periodically, and when we've got the complete pump, and we will actually roll the entire pump over instead of just rolling the shaft. You got to remember that weight of that pump shaft is sitting on the bearings in that pump.
You don't balance that before it goes in? The whole thing is
No,
assembled?
you don't have to balance the entire, put all the impellers on.
What was the RPM again, 18 or 17?
1200.
1200, okay,
Yep.
that helps.
Yep. You can see that they've had a big rain. You can see that the river's all muddy now. So we can release the barge, but the divers couldn't go back in just because the level of the water was up. We moved the motor that we had reconditioned, and we moved it into a storage room there on site just to get it out of the weather. In that storage room, we energized the heaters to keep all the windings good. And that's the same room that we store the pump in. We had a very successful job here. Motor and pump were removed from the pump house. They were transported to HECO Kentucky Service trucks on the barge. Everything was brought to the workshop. Spare pump was assembled on site, and the spare pump was actually put in the hole. And that was just to speed up the repair. Motor was reconditioned and returned. Spare pump, of course, as I said, was installed. Motor's installed, wired, and commissioned. Ready to push the button for Mr. Customer. All of this work was performed within 1 month, and it was due to the barge cost. As I said, it's $83,000 for 30 days. Day 31, Justin hates for me to have to write another check. I hate to have to write another check also. Customer is happy now that he is pumping drinking water again. He's back up to full capacity. So he's ready. He's really happy now. Now the staffing we had on this project, we had a project manager, which was an engineer that we have on staff. A team leader was down there full time. I had 4 service technicians, field service technicians on site, and plus the entire workshop was working on it. Any questions, comments, complaints?
How long was that pump in service? How long was the pump in service?
How long was what
The
now?
pump in service, how long were they between changes?
Oh, between changes, about 6 to 7 years.
What are you guys' balance specs for your colors?
1.0. We balance everything to 1.0. The manufacturers balance pump impeller, these pump impellers, 6.3. You know, that's why you had asked if we did the entire unit together. We do not. Everything's on a key.
It's hard to believe all the length of it, which don't get whipped and all sorts of things. And when you said those bearings go out.
Oh yeah, and when they go out, you know it. One thing
Do
that
they
we
have
add,
monitors on it so they know?
one thing that we started adding about 8 years ago, we actually put vibration monitors on the pump.
Okay.
And so we can come in at any time. Actually, they can tie them into their SCADA system, or we can go down there and actually plug in right there at the pump.
It's fairly inexpensive to do that too.
It is, yeah. It's a lot cheaper to put those on and monitor it than it is to pull this thing
But
out.
the diver's the one that actually couples it together.
No,
as a
sir.
pump.
No, sir. We put the. You're talking the vibration monitor.
What's the diver for?
The diver is to put the to remove the anti-vortex and put it back on.
What do you call it?
It's an anti-vortex, not enclosure, but it's a device that keeps the water from doing this.
Keep the big chunks out.
No, they have screens to keep the big chunks out. But you saw in one of those pictures, they get a lot of sand in it, and they do get some trash in it.
So you don't get a whirlpool.
That's why you get the anti-vortex, keep the whirlpooling down. And that's what I said, when they first put these in, that was the problem that they had. These pumps were running in the whirlpool effect down in the caisson where these pumps sit was just unbelievable. You get fish that come through there also.
So Charlie, you have to remove that anti-vortex thing because you couldn't pull it up through the hole?
It's bolted down to the bottom. It's bolted to the bottom of the pump, and it's bolted down to the bottom of the caisson.
Gotcha.
So it doesn't come out with the pump.
Is there a certain time of the year that we do that?
Whenever customer needs it.
Whenever it's.
Yep. Now let's see here.
Charlie, if you guys get the impellers re-Belzona coated,
Yep.
you do your balance before or after Belzona coating?
After. And then the question is, how do you make corrections?
We grind it off.
Yeah, you have to grind a little bit off.